Chapter 5, Lesson 5.1, solving systems by either graphing or by substitution. First, this was just like what we did after the test, except for this terminology. A system of linear equations, like I got a red line here and I got a green line right here. The solutions are like wherever those intersect each other at. How many times in this first one do they intersect? Once. So there is one solution to this guy. But then we get some fancy terminology on this, and it's going to take a little repeat process. It's going to be weird at first. The terminology, if this guy has one solution, means he is a consistent system. So that system is called consistent. Got to spell it right. Consistent. The weird thing is at the end it looks like it should be T-I-N-T, but it's T-E-N-T, like you're sleeping in a tent. So it's consistent. So consistent means you got answers, right? Wasn't there one answer to this? And then the independent part means there was just one answer to it. So that system, since it had an answer, it's called consistent. And since it only had one answer, it's called independent. Then you also had a situation where you graphed this green line right here, and then you graphed the red line, and they were like right on top of each other. How many times do they intersect? Infinite number of times. Got to spell it correct. Infinite. Every vowel is an I, except for the last one is an E. Infinite. There are infinite solutions, which we're going to learn way more about today. But that is a consistent system because we got answers. But he would be called dependent. Again, once we dive deeper into this, we'll kind of get what that dependent part is. But consistent means you got answers. Dependent means, for lack of better things, there's more than one answer in this case, right? There's more than one. It depends on what the answer is. And then here, these lines were parallel to each other. So could you tell me how many times do they intersect? They do not. So there is no solutions. That is an inconsistent system. No solutions, which means it's inconsistent. Then you can't be dependent or independent if there's no answers, right? Again, that's all crazy weird stuff. It gets better as we do it, right? It's like riding a bike. You know, the first time you might fall down. The second time, once you get used to it, it's like, all right, I got this thing. So cool thing is, you already know how to do the next one, solve by graphing, but please follow my lead because the human drawing part is very inaccurate. Like drawing these by hand, I know we're going to graph them, but it's still very inaccurate. So check it out. I want to solve these by graphing. It's nice if y is by itself. In red box is that guy, is y all by itself. Cool. Who's the y-intercept? -3. So let's start there. And then the slope, what should I do? First of all, it's -1. What should I do? What's my moves? Down 1, then where? I can go over 2 ways, to the left or to the right. Which way would you like me to go? I'll go down 1, then where? To the right 1. Down 1 to the right 1. Here's where human error comes in. I need you to put a bunch of points. You'll see why in a second. I'm also going to go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. I need a bunch of points. A bunch of points. Like, holy cow, man. Not necessarily all of them, but a bunch of points. Then take your straight edge. And please, like this freehand and stuff has to stop, guys. Use your straight edge to connect those dots together. So there's my green line. I'm looking to see if I graph this green line and I graph this red line, if they intersect or not. Maybe they're right on top of each other. Isn't y all by himself in the second one? So I'll start right here and then kind of watch my lead here. I'm going to start at -1 on the y-axis. So this is where you could get a little lost. The slope is 1, correct? Rise 1, run 1. Rise 1, run 1. I would like you to watch me do this. I'm going to rise 1, run 1. Rise 1, run 1. Stop, stop. Just watch. Rise 1, run 1. Rise 1, run 1. And I could keep going. Are my dots getting closer to that green line or further away from that green line? They're getting further away. I'm trying to figure out where I can get a red dot on top of a green dot because I want to know where these intersect at. Are you with me on that? So going further out that way is probably a mistake. Instead of going up 1 to the right 1, what could I do instead? Down 1 to the left 1. Boom! Did I get a red dot on top of a green dot? Yes. Even though that is the answer to the question, finish what you're doing. Let's connect the dots. You don't need to keep putting more points. That's only on the first line. You want to put a bunch of dots, right? On the second one, once you can get a red dot on top of a green dot, we shall connect the dots. Cool? So you tell me, does this system of equations, which doesn't make sense until we put a story with them, we'll do that next time, does this system of equations have one solution, no solutions, or infinite solutions? One solution. Where is it at? What is this ordered pair right here? If you was to put that on a graph, where is that guy? -1, -2. What do you think? Does it need to be in parentheses? That's a big fat yes. You must have it in parentheses. And then when they say classify the system, so we found the solutions. If there's one solution, we'll just list it. That's the solution. Now we'll classify it. Look up top to those little verbiages. Is this consistent or inconsistent? Let me ask this. Did we get an answer or did we have no answers? Did we get an answer? Yes. We got an answer. So what is that? Consistent or inconsistent? So that is consistent. Consistent. Then I need to know how many answers we got. When you graph two lines, you can either just get one answer or infinite answers, right? There's no way that two lines could intersect twice because then it would turn into a curve. Are you with me? We're just doing lines, right? So did I get one answer or did I get infinite answers? One answer. What do you think? Independent or dependent? Independent. If you are an independent person, you are all alone. Independent. Please spell them correctly. So it's consistent because we got an answer. It's independent because there was just one answer. Cool? That's what classifying it means. Let's try again. This guy, green machine, can I graph him right now? Yes or no? Yeah, Y's all by himself. So first one, we're going to put as many dots as we can. I'll show you why on maybe like the fourth one. So down one to the right one, down one to the right one, down one to the right one. It's kind of weird. We're going to end up graphing this line a lot today. I don't know why I haven't changed the worksheet to do other equations. So now on homework, when you graph the lines on the computer, you still just plot 2 points. But the computer is accurate. You know what I mean? The computer will connect the dots perfectly for you. Your human error of putting your straight edge on here perfectly doesn't necessarily work. You know, I'm not blaming anybody, but human eyes are different. Our pencils are different thicknesses. Did you line the straight edge up perfectly or not? So the more dots you can get, the better. Oh no! That one's not ready. Let's get y all by itself. What's my first move to get y all by itself? Subtract 2x over. Should it be a 2x or a minus 2x, y'all? Minus 2x. There's a minus 6. Yeah. Then we will divide every term by 2. Showing baby steps is perfectly fine. You don't have to at this stage, but you can. Y equals -2 over 2 simplifies to be -1x minus 3. Oh my goodness. What do you notice? That's the same line that we did before. No need to graph it a second time. It's going to be the same one. So you don't have to do it twice, right? Maybe on the computer you do. I haven't checked that out. You might have to do it twice. I'm not sure. How many solutions will this have? Infinite solutions. And here's where the video that you watch after the test didn't finish this. I got a question for you. Just watch me. Is this a solution to the system? Nah, it's not on those lines. Is this a solution to the system? Nope. Is this a solution? How many times could I not put a dot on the lines? An infinite number of times. Is this a solution to the system? Yeah. Is this a solution? So would you believe there are an infinite number of solutions, but there are also an infinite number of wrong answers to this as well. So here's what we'll do. We'll say infinite solutions. Infinite solutions. And this takes practice. In the form. Infinite solutions in the form. I got to give you the key to the puzzle. Like if I gave you an x value, you could figure out what y would be, right? So just follow my lead. Don't write until I tell you to. You see, I'm going to put an ordered pair here. Just kind of watch this. I got a question. Don't ordered pairs always go x comma y? Yes or no, right? So here's what we got to do. In the first spot, you can write that. You can put the parentheses and put an x. And then what we do in the second spot, we're not going to put the letter y. You're going to tell me what y equals. And you already know what y equals. Could you tell me what y equals? What does it say that y equals? Y equals how much? -x minus 3. That is the combination to unlock every possible solution. So watch this. I will make up an x value. Cool? 7. Let's say x was 7. Then if I put 7 in right here, I would get negative 7 minus 3. Would you believe negative 10 is the y value in that scenario? Is 7, negative 10, a solution to this system? 7, negative 10. Bing! What do you think? Is that a solution to that system? Yes or no? What if I put 0 in for x? What would this turn out to be? Negative 0 minus 3 is how much? Negative 3 is 0. Negative 3, a solution to that system. Yes or no? What if I put 1 in for x? Wouldn't this be negative 1 minus 3, which is negative 4? Is that a solution to this system? Any x value I make up, if I then take a negative 1 times it and subtract 3, would you believe that that would be on that system in that case, right? This is the combination to the lock that says, hey, who are the solutions? So here's one. What about 2, 5? Is 2, 5 a solution to this system? If x is 2, does this turn out to be 5? Negative 2 minus 3, is that 5? Okay. Now we got to classify it. Did we get answers? Are there answers to this? Yes or no? So consistent or inconsistent? Consistent. Did we get one answer or more than one answer? More than one. Dependent or independent? So that is dependent. Don't you worry, friends. That's only 2 examples. It gets so much easier. You just got to practice it, man. It gets so much easier. So let's rock this next guy right here. First guy, graph him, man. I like him. He's got a y-intercept of 5. Down 2, to the right 3. Do it as many times as you can. Down 2, to the right 3. Go up 2, to the left 3. Up 2, to the left 3. Then connect those dots, baby. Then take the bottom one with the neighbor, pause the video, and get y all by himself. So we will subtract 4x over. And then I will divide every term by 6, right? I'll answer your question right now. Do you think we should reduce the fractions, like negative 4 over 6? You think we should reduce it? What's that reduce to, baby? Not 2/3, but negative 2/3. Oh, bro, is this line and this line the same one? Nope. What's different about them? The y-intercept. Cool. So I'll graph him. He's got a y-intercept of 2. And I'm going to go down 2 to the right 3. Down 2 to the right 3. Down 2 to the right 3. Bro, I am not getting a red dot to be close to being on top of a green dot. Why not? What's true about these 2 lines? They have the same slope, which means they are what kind of lines? Parallel to each other. So you graph those bad boys. And I got to ask you this. How many solutions would that have? 1 solution, no solutions, or infinite solutions? No solutions, which is my favorite. No solutions. Because classifying it is the least amount of work. Did we get answers? Yes or no? So dependent or, consistent or inconsistent? That is inconsistent. Inconsistent. Then you can't do dependent or independent because there's no answers, man. Weird, man. Weird, weird, weird. Let's do one more, baby. One more. Ah, crap. We got to put both of them in slope-intercept form. So what I like to do is this. I like to move this guy down yonder. You know, it's like I'm going to bring him down here so that way I can do my second one right underneath that problem. Like, why do this one right here when I could do the red one underneath there? So I'm going to move this guy down. What's the first move you do in that green box? What would be the first thing you do? Subtract 2x. So why rewrite that? I'm going to do it in green so we can just kind of stay. So I'm going to subtract 2x as my first move, right? subtract 2x. Then I'll divide everybody by 2. And then I think you should graph that line before you go do any other work. Get a line, graph him. So we'll go to -3. Here's that same old boy. I don't know why out of these 4 problems this line showed up 3 of the 4 times. But man, if you don't put all these dots, I really doubt that you're going to get your line nice where it's supposed to be. You probably won't find a red dot on top of a green dot. You'll be like, mine didn't intersect at a nice place. It's because your line was very inaccurate due to human error. And it's like, oh, now I see why you want me to put all these dots on the first one. So I'll connect the dots together, and then I'm going to do the other one just right underneath this. So I'm going to do y equals -3x plus 3. That was easy money. And graph that guy. And let's see if I get a red dot on top of a green dot. So I'm starting at 3, down 3, to the right 1, down 3, to the right 1. Can you notice my dots are getting closer to the green line though? Like I was going down 3 to the right 1, down 3 to the right 1. But I'm still not there. I'm going to go down 3, 1, 2, 3 to the right 1. Boom! Did I get a red dot on top of a green dot in that case? So connect those bad boys together. Here's some good troubleshooting. What if you never got the dots to line on top of each other? You may have made a sign error somewhere in trying to get y all by itself. It's like, this didn't work out at all. You know, something could have went wrong. What do you think? One solution, no solution, or infinite solutions? One solution. I guess we don't write it. What is that one solution? Where is that guy, bad boy at? Is he at 3, -6, or -6, 3? X first, y second. Put him in parentheses. Classify him. Since there is one answer, is it consistent or inconsistent? Consistent, and since there is one, how do you feel about independence? That is my least favorite way ever to solve linear systems, by graphing. What a waste of time. It's nice in a visual representative when we start doing some story problems. It's nice to see things, but algebra is so much faster, baby. So that's why the backside, we are going to solve this systems by substitution. There are many ways to solve a system. One is by graphing, one is by substitution, another one is by elimination. Then we can use matrices. That's in Algebra 2. There are so many ways to do it. Here's what substitution is. Could you do me a favor and read what's in this red box? You will choose to solve a system by substitution if, do you see these two equations? I just like using the colors red and green. You see I have like a red line and a green line right here, right? In either one of those, do I have a variable all by himself on one side of the equal sign? Actually, in both of them, right? It doesn't have to be in both of them. I just need one of them. So here's what I like to do. Please trust in this process. I've been doing this for over 20 years. Let's take this top equation and let's put a box around this right here. Please put a box around that. And what does this box equal as a letter? Would you agree it equals y? Are you with me on that? So if I told you x equals 2, are you guys down with the fact that anywhere you see an x, you could substitute 2 in its place? Are you with me on that? Well, anywhere I see a y, I could substitute 5x minus 25 in its place, because isn't 5x minus 25 equal to y? So what we do on the one equation is we put a box, and the other one we will put parentheses. Why did I put parentheses around the y? Because isn't that what the box is equal to, right? The box equals y. And here's how you substitute. It's a real simple game. Take what's in the box and put it in the parentheses. So I'm going to just write this whole thing. I got a parenthesis right there. How do you feel about 5x minus 25 goes in the parentheses? The y is gone, right? I have substituted 5x minus 25 in its place, and I'm going to copy everything else down. It's going to take a little practice, but you cool with this entire red statement that I have highlighted is exactly the same right here, except for what's in the box has now went into the parentheses, yes? You know why this new line right here is amazing? How many different letters do you see? Only x's, only y's, or both of them? What do you see? There are only x's. This red dude sucks. It's got x's and y's with it. This green guy sucks. It's got x's and y's with it. I wanted to get this orange thing that only has x's with it because we dominate solving that for x. Are we cool with that? Can we get x all by itself? Here's my question. Is there a number outside the parentheses besides 1 or anything like that? Is there a number out there that needs to be distributed? So those parentheses don't necessarily matter. So I'm going to now kind of just like erase them a little bit. I don't care if you erase them or not, but they didn't matter because there was no number outside of them. Here's what I want to do. I want to move this negative 8x over to the other side. How do you move a minus 8x over to the other side? Add. So 5x plus 8x is 13x. Then minus 25 comes down, and 27 is still right there. It's going back to chapter 1 stuff, right? So then, isn't there a minus 25 that needs to move over to the other side? So I will add 25. Grab a calculator if you need it. 27 plus 25. Got a vote for 52. Are we agreeing with that? Do your own work, Nama. Get 52? Yes or no? What's the last move right there? To get x all by itself, what would you do? Divide by 13, right? So you can punch that in if you need to. If you are a card player, you're really good at that because there are 52 cards in the deck and 13 cards in each suit. That would be how much? 4. That is not the answer to our system. That is half the answer. Back here, when we got an answer, isn't there an x value and a y value to it? Like we're looking to see where these lines intersect if we were to graph them. We have figured out that x equals 4. Then please draw this arrow. We are now going to go find y by substituting 4 in for x back into the box. So draw this arrow. You're going to put 4 back in the box. And we can do a little mental math on this. Let me erase that little nug right there. I'm going to do y equals, right here is 5 times 4, right? I'm putting 4 in for x. What's 5 times 4? 20 minus 25. And then you just clean up, what is 20 minus 25? Not 5, but sign errors are going to kick our butts this chapter. Let's take our time. Hey, I'm just as guilty as making sign errors, but I'm just telling you, slow down. We can do it, right? I know we can. So negative 5 is the y value. I would like to write this as an ordered pair. So what do you think? 4 negative 5 or negative 5 4? X first, y second. That, if I graphed those two lines, they would intersect at the point 4 negative 5. So how many solutions did I have? One solution. No solutions or infinite solutions. One solution, which is consistent. And what else? Is it consistent and independent or consistent and dependent? There's just one answer. And independent. A lot of people ask a great question like, didn't we get 2 answers? Didn't we get an x and a y? You're not wrong, but those two made 1 point. Are you with me on that? They made 1 point on the graph. Holy cow, if we stopped right there, you would be confused as heck, right? We need to do more to get better at this, right? So I want to solve this by substitution. Here's what I'm looking for. I got me a green line. I got me a red line. Do any of those have a variable all by themselves on one side of the equal sign? Yes or no? Yep, top one or bottom one? Nope, not both. Because the other one is y plus x equals 21. Isn't y and x on the same side of the equal sign? Are you with me on that? So which one, top one or bottom one? Bottom one. The one with the variable all by itself is where the box goes. Box. The box is where the variable who's all by himself goes. What does that box equal? Because it doesn't have to equal y. In this case, it does. It could equal x. What does it equal in this case? That's what you go put parentheses around in the other equation. And here's how we substitute. We take what's in the box and put it in the parentheses. Question for you. Do the parentheses matter? No. Is there a number in front of y? Is it like 2y, 7y, a million y, or is it just y? So the parentheses don't actually matter. So we can take what's in the box, 3 plus x, and it went in there. I'm going to put it in parentheses just so your brain doesn't get overloaded, because I could see some people got confused by that. So I took what's in the box and put it in parentheses. Then I'm going to copy the rest of this down. It is plus x equals 21. How do you feel about the top line, the parenthesis line, is literally exactly the same, except I took what's in the box and I put him in the parentheses. Yes, no, maybe? Here's where you know if the parentheses matter. Is there a number outside of the parentheses besides 1? So that's why it didn't matter. You're just going to distribute a 1 through there. So now let's kind of talk about these. This is really 3 plus x equals 21. I don't care that you rewrote it again. But are these like terms? Yes or no? Are they on the same side or different sides of the equation? Same side. No moving them around. How many x's is that? 1x plus 1x is really what? So this is really 3 plus 2x equals 21. Are you with me on that? Get x all by itself, baby. So we shall subtract the 3 over. So 21 minus 3 is 18. And then we divide by 2. And that would give us 9 back. Does that sound okay? That's half your answer. We are looking for the ordered pair to where these guys intersect each other at. How do I find the other one? Arrow. I'm going to make you draw it. You know you're going to show all this work on your own piece of paper, right? So you're going to draw this arrow, and where does it go? Into the box. If you can do that mentally, I don't need any work shown on that. Isn't it just 3 plus x? If x is 9, what's 3 plus 9, baby? So y equals 12. Write that as an ordered pair. And then classify him. Is that consistent or inconsistent? Dependent or independent? What do you think? Consistent or inconsistent? Consistent. And then since we got one answer, independent or dependent? Independent. Weird stuff. Consistent and independent. It gets easier. You got to believe me. Next one. I would like to solve these by substitution. I'm not even giving you a choice. Your entire test, you will choose how to solve the system, right? I'm going to solve this by substitution because here's what I'm looking for. Out of these two equations, is there an equation with a letter all by himself on one side of the equal sign? Which one? Top one or bottom one? That's the box. The box goes around that. You see how y is all by himself on one side of the equal sign. So now we get to have some fun. Slow down. What does the parentheses go around? Whatever letter was all by itself. Which letter would that be in this case? Y. We've had 3 for 3 that it's going to be y. It won't always be y. Sometimes it's x. Are you with me on that? So check that out. Do you think those parentheses matter now? Yes or no? They definitely matter because there's a 3 in front of it. Cool? So take what's in the box and put it in the parentheses. Give it a shot by yourself. See what happens. Create something. So I took what's in the box and put it in parentheses. I should reiterate why we're doing that. This is amazing because doesn't this new equation only have x's with it, right? I can totally solve for x. If it has x's and y's, it's impossible to solve for x and not have a y in your answer. It's impossible to solve for y and not have an x in your answer. So we're trying to make something go away. Cool. Let's distribute Mr. 3 through. 3 times negative 4 is negative 12, and there'll be an x next to it, right? You might need to punch in 3 times 15. What's 3 times 15, my friends? 45. Good question. Been a while here. Does this 3 need to be distributed to that negative 4x? It's not in parentheses, so it's just still a minus 4x, right? And the same thing with this negative 3 on the outside. It doesn't get distributed to. Are we groovy with that? Talk to me about these x's. Same side or different side of the equal sign. Combine them together. A negative 12x and a negative 4x. Negative 16x. Yeah. Then we will subtract 45 over. And here's where your brain might let you down, dude. Should that be a positive or a negative number when I'm on? It is a negative divided by a negative, which turns out to be a positive. Positive what? 3? Cool. We have found half our answer. How do I find the other half? take that, put it in the box, right? Substitute it back into the box. So I will do a little bit of that mentally. Negative 4 times 3 is a negative 12 plus 15 more. And y turned out to be 3. So that's cool. You can get that ordered pair right either way because they're both 3, 3. Consistent or inconsistent, dependent or independent, that's what you'll decide. Yeah. Boo! Algebra. Are we getting more comfortable of what I'm trying to do here, though, right? You know, it's like, all right, I see what's going on. Hey, even though you don't know how to solve by elimination, why is solving by substitution the best way to do this system? Tell your neighbor. How do you know? There's a variable. It's in the red box that I made you do right here, which is a test question. When would you solve a system by substitution? When you have a variable what? All by itself on one side of the equal sign. Put a box around that, please. Put a box. How do you feel about this? Yes? Where does the parenthesis go? Around what letter? Now, 4 for 4. It's not always y. It's whatever the box is equal to. In this case, it is y, right? So I will put that around here. And then I'll rewrite this guy and make it as easy as pie. It's 2 times 2, right? Which is 4. So easy that it's hard. What would you do to solve for x, baby? Subtract 4. Tell me what you get. 8, negative 8, 0, or negative 4. What do you get? 0. 0. And now, the most brain farty thing that happens. How do you solve for y? How do you solve for y? Put 0 in the box. I can't put it in there. What does that line say? What does it say? Y equals 2. It told you what y was. Guess what y is? 2. We found x. So our ordered pair is 0, 2. Easier than pi because they gave you half the answer already. They told you y was 2. And then let's classify them out loud. Say a little time. Consistent or inconsistent? Dependent or independent? Did I get an answer? Or did I get infinite answers? Why did I get infinite answers? Okay, cool. So you're telling me that a horizontal line and an oblique line intercept infinitely? Or is that just one ordered pair? One ordered pair. But have you noticed we haven't had no solutions show up yet or infinite solutions show up yet? So we can't quite quit and get ready for craziness. Oh no. Is there a variable all by itself on one side of the equal sign, guys? Yes or no? Put a box around it. It's this one. And double whammy. First, who does the parentheses go around in the other equation? X. Shh. What about that negative? Should it be in the parentheses or outside the parentheses? It's got to be outside. Outside the parentheses. All right, outside. Take what's in the box and put him in parentheses. How do you feel about that? It's weird. It's weird. But does it only have y's with it? Right? That's cool. I can solve then. It doesn't have x's, a, and y. Is there a number outside the parentheses that needs distributed to? Yep, negative 1. So let's distribute that guy. And here's my question. I can see we're getting a little tired, which is normal. See those? They are like terms. Are they on the same side or different sides? Same side. So we'll combine them together. Tell your neighbor what you get. How many y's is that? If you lost $1, then gained $1, what do you got? You lost $1 and then gained $1. You have no dollars. Negative 1 plus 1 is how much? 0. you have 0 y's, which we will not write that down like this. This is silly. What does 0y turn out to be when you multiply that out? It's 0. Would you believe that these add up to be nothing? So they are gone. No y's. You are left with 1 equals negative 1. All the letters have disappeared. That means one solution is not possible. Are you with me on that? Every time up to this we have had a letter left, we got one answer. It was consistent and independent, right? This is either no solutions or infinite solutions. But how do you tell? You ask yourself this question as yes or no. Does 1 equal negative 1? Yes or no? No. So what do you think? No solutions. No solutions. Classify. Is that consistent or inconsistent? Inconsistent. All the letters disappeared. But hey, what if it said this? 1 equals 1. Yes or no? How many times will 1 equal 1? Every freaking time of your life. How many solutions would that be? No solutions or infinite solutions? That would be infinite solutions. But it wasn't. It was 1 equals negative 1. So let's try one more, baby. Right? One more. Hey, guess what it's going to be? It hasn't shown up yet. Guess what it's got to be? How many solutions has it got to be? It's going to be infinite solutions, right? So let's see how it works. Box and parentheses. Which one gets the box? Top line or bottom line? Top. And what should I put parentheses around in the bottom line? And around y. And those parentheses definitely matter. Negative 6x minus 2 times negative 3x plus 4 equals negative 8. Don't forget, the concept is to rewrite the bottom line all over again, but what's in the box goes in parentheses. And here's a good question. What number needs to be distributed, 2 or negative 2? It is a negative 2, right? So we'll distribute the negative 2. What's negative 2 times negative 3x? Positive 6x, right? Then we get a minus 8. And here's what happens. I'm going to combine those x's together. It is a negative 6x plus a positive 6x, which is how many x? It's gone. If all the letters disappear, one solution is not possible. It is either infinite solutions or no solutions. So you got to read what the leftovers say and just play yes or no. Does negative 8 equal negative 8? Yes or no? Yes. So that means we have the real big long answer. Infinite solutions in the form and here's what I got to train you to do. First of all, if you have questions with this, I will help you at any time, right, until we take the quizzes. But it's going to go x comma y. You'll always let x be x, and you got to know what y equals. Can you look up to the given equations? Do you already know what y equals? What does y equal? Yes. So don't put this. This is bad. This is so close, but so wrong. Do you see how I also have the y equals in there? You don't want the y equals in there. You only want the negative 3x plus 4. Since we just wrote all of that, would you believe the most missed thing on the test is to classify this? Is that consistent or inconsistent? Consistent. Dependent or independent? This is dependent because there is more than one answer. Let me see if that makes sense to you. Tell me the answer to this. And I'll go, okay, it depends. All you got to do is tell me an x value. Give me an x value. 2. 2. Negative 3 times 2 is negative 6, plus 4 more is negative 2. So 2, negative 2 is an answer to this. Give me an x value. 6. 6 negative 18 plus 4 is negative 14. 6 negative 14. What's the answer? It depends. It depends on what you tell me for x. Because whatever you tell me for x, all I got to do is take negative 3 times it and then add 4 more, and that will be a solution to this system. What a day, baby.